As we get started today, turn your textbooks to page 428. We're going to start by looking at the review, numbers 7 through 12 that you did for homework. You also had 11, 12, 14, and 15 from... I see 11 and 12. What happened to 14 and 15? Brecken's like, it's not me! Not sure what happened there, Noah. And everything else, 11, 12, 15, 14, is that?
It's swapped.
It's swapped. Okay, that makes more sense. I was like, that just seems really odd, you just randomly stopped. Yeah. That's the 11, 12, 14, 15. That's the 7 through 12. All right, we're good. We're good. All right. So looking at the review, 7 through 12, just adding fractions together. These fractions already have, Maddie, and you have to have a common denominator in order to add them. So if they didn't have a common denominator, we couldn't add them, at least not the way that they're written here. And number 7, what did you get for your answer?
4 times 3x plus 1 over 4.
Good. Initially 12x plus 4 over 4, but you factored out the 4, which you said gave you 4 times 3x plus 1 over 4. But thoughts, Maddie? So our final answer comes to just... Good, 3x plus 1. You could leave it over 1 or don't bother. Good, number 8. What did you get for your answer, Noah?
Negative 6a squared plus 9a over 12a.
All right, so we've got a negative 6a squared plus 9a. No, plus what?
Yeah, 9a.
Over 12a. Just see if I remembered what you said correctly. Now, we wouldn't want to leave this, though, right? No, not with a negative first term. What should I do with that negative? Well, does this apply to the whole numerator or just to the 6a squared? So if it applied to the whole numerator, I could move it to the front. So I've got two options here.
Negative a.
Right, I would factor out not just a negative a, there's more than just a negative a, there's a negative 3a. Right, I would factor out the negative 3a to leave you with
2a plus 3a. Negative.
Sign, number, letter.
Negative 3a. Or negative 3.
Good, just negative 3 because the a's would cancel, wouldn't they? And then from here, notice we could cancel the 3 with the 12 to get a 1 and 4. I could cancel the a, and then the negative would come out front to give us negative 2a negative 3 over 4. We did cancel away an a, so no, we need to specify that a cannot be 0. Now, that's one way to do it. The other way to do it would be to say, well, let's just flip-flop these two numbers and say 9a or negative 6a squared over 12a. Now I don't have to factor out a negative, do I? But, Maddie, I should still factor out a 3a, right? Even if it's not a negative, I should still get the 3a out to leave me with... And then still I can cancel away the... to get right, so either one of these answers would be correct. It just depends on how you wanted to express it. But again, look for opportunities to reduce. Maddie, you even went ahead and factored. You either didn't cancel or you went and gave me this answer, and then so, you know, because you had to think like a teacher, like, you know, it would really help him if I gave him the factored answer first so he could show the rest of the class how it cancels. Maybe you thought that far ahead. Did you? Okay, I didn't think so, but I'm like, you know, some people really do just think like that. You know what? I know what he doesn't really want my final answer. He wants my preliminary answer so he can show the ending. Here, factor, cancel, right? And be careful with that negative. Taking a look at number 9. What did you get for your answer? Back to Maddie. I think that doesn't sound quite right here. So well, let's just work it out here. We draw a long line. Underneath the long line we put... And above the long line, what do we copy down? There we go, okay? And notice they went ahead and added the inverse for us. That probably should have been a subtraction problem. And then they went ahead and made it a plus with a negative in front of the entire numerator here. Maddie, we do need to combine some terms, but it's these two that combine. I feel like maybe try to combine the 4x squared with something. Should we have gotten a 4x squared? Negative 14x negative 8 all over the 2x negative 8. Is that what you did? You tried to combine the 4x squared maybe with the 6x or something? Oh, so you reduced each fraction right off the bat. Is that what you did? You actually could do that here.
Yeah, I factored.
You factored before you did the addition. I would normally wait to factor till after, just because it's going to make your life easier, because right now you have the common denominator, right? If you factor and cancel, now it happens you could still have the common denominator, right? But sometimes you may not. So I would advise waiting until the very end to do any reducing here. We still can factor the same 2's that we would have factored twice, right, to reduce and cancel. Now we would have to do it once. Pull out the 2 to get... And for that matter, that can factor further, Maddie, into... You're factoring a 4, 1 and 4. All right, check your outer, inner. Right, just switch the signs. There we go. And what about in the denominator here? To get... Oh, thoughts, Maddie? To get just where x cannot be. Good, as you move the negative 4 over, x can't be positive 4. Now again, here's the thing. With multiplication, we always factored first, right? We factored everything we could and we tried to cancel everything we could. With addition, you've got to think it a little bit differently. With addition, wait till the end. Don't factor anything until the end. It's just going to make your life easier. Does that make sense? All right. So with multiplication, the whole purpose is cancel, 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 right? And you can only cancel factors, so you factor, so you can cancel, 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 and then multiply. With addition, it's all about the common denominator, and once you have it, big long line, get your numerators down, combine it all together, and then at the end, wait and see. Can you do anything? And if you can, go ahead and take care of it. I'll say this. If you could have factored at the beginning, you'll be able to factor at the end. Okay? If there's factorable material at the beginning, there will be factorable material at the end you can still use. So for instance, on number 10, technically neither of those numerators factors, okay? But they kind of look like maybe they would. Don't even bother. Wait until the end. We're going to start by drawing, Noah, the long line. Start with the big long line. You may want to write that down in your notes. Start with the big long line. Underneath the big long line, just put x plus 3. Just write it out one time. Then above the line, normally I'd say copy out your numerators. But I think with an addition especially, we could probably do this in our head, Noah. Let's combine the x squareds. Let's combine the x's, the negative 9x and positive 4x.
Negative 5x.
And let's combine the constants, the 4 and the negative 6.
Negative 2.
All right, now, trinomial probably ought to see if it could factor, right? That'd be a smart idea. But question, class, when is the only time it would help me to factor? If I could then follow it up by canceling, right? Does it help me to factor this if I can't get any cancelable stuff? No. Well, is there any way I could factor this to get an x? Well, sure, 2x and 1x, right? Is there any way to get a positive with the x? Sure, negative positive, because the signs have to be different. Is there any way to get a 3? Wait a sec, can you split up a 2 to get 3 in anything? No. So even if it does factor, neither of the factors would cancel anyway. So why bother? There's my answer. Does that make sense? But follow that process, okay? Big long line, put the denominator underneath of it, figure out your numerator. And then at the end, maybe I can factor and cancel. Does that make sense? So multiplication was all about factoring. Addition is less about factoring. Make sense? Okay, so just making that adjustment in our minds. Number 11 then, Maddie, let's go ahead and work this one out. We need a really, really long line here, don't we? Because we have 3 different fractions we're combining together. What goes under the big long line though, Maddie? Just x plus 5. Now above the big long line, Maddie, let's copy out numerators because there's a distribution I'm going to have to do later on. So instead of trying to combine anything too quickly, let's just write it out. So tell me what to write down here. Well, let's do that distribution at least, okay? There we go. So again, instead of trying to combine anything too quickly, let's take care of the distribution, just copy everything else. And when we do, Maddie, we're able to... All right, so as I look to combine stuff, now my x cubed is by itself. So just... And then I've got several constants here. 115. And there's our answer there. All right? Did either of you get this answer by any chance? All right, good. No. Okay, Maddie, does it make sense the process now? Okay, I've had a chance to work on it a little bit in class yesterday. Practice for homework tonight, hopefully beginning to flow for us here. Number 12, Noah, walk me through. What do we do?
Well, big long line. And then put 2x underneath. And put 5x plus 6. Plus 3, negative 4x, negative 2x, negative 1.
Great job. It was a subtraction, add the inverse. And anytime I see a subtraction, I like that Noah didn't try to combine too early. Because of the subtraction, if you try to combine early, you're probably going to screw something up. So just copy them down, okay? It's not going to take that much more work for you. All right, let's combine now the x's.
Negative 2x.
I've got a negative 4, negative 2.
Negative 1x.
Right, that's a negative 6. Put that with the positive 5 gives us... Now here's the deal. I don't want to lead with a negative anyway. So I'm going to put the negative 1x at the end. Lazy, smart, right? And then when I combine the constants, I get positive 8. Now I don't have to worry about pulling out a negative. All right, now if you did have a negative x positive 8, you have to factor out the negative x negative 8 and then slide the negative to the front. I'm too lazy for that. 8 negative x all over 2x is our answer. Did either of you happen to get that for number 12? All right, does it make sense now? All right. You'll practice with some more of those for homework tonight as well. So we are just going to continue working on it as we go along. Turn back a page, if you would, to page 427. And we've begun looking at equivalent fractions at the end of the hour yesterday. We actually didn't get to cover quite as much as I wanted. So the homework assignment was more of a, let's just see how it goes. If it didn't go well, no big deal. This, I felt, should have gone a little better than it did, just to be really, really frank, because we had done it a few times. The next part of the homework, we barely looked at. So it was just kind of a, hey, let's see how it goes. Maybe you do well, maybe you don't. But if not, well, give me a chance to address any missteps we have. With equivalent fractions, the key is to change the denominator from something you got to something you want. And the something you want, always, 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 will have had something multiplied by what you had. So the strategy is, look at what you want to get, Maddie, and factor it. And when you see the factors, you'll be like, hey, look at all this stuff that's here. Look at what I started with. Hey, that wasn't there before. And if it wasn't there before, put it in the numerator too. Make sense? So let's see how we did on the homework. You had number 11. They started you off with an x positive 3 over x negative 4. And they wanted you to make an equivalent fraction whose denominator was x negative 4, x positive 2. Now it's already in factored form. So Maddie, as we look at this and we like, x negative 4, x negative 4, x positive 2, something changed. What changed? The x positive 2 obviously changed. And since that's what changed, it changed in the bottom. That means it's got to change class in the top as well to make it equivalent. So I also need an x positive 2 at the top. Maddie, what is our numerator? Well, I was gonna foil it, but
squared plus 5x plus 5, 6.
There we go. And there's our new numerator. Now, if you left it x positive 3, x positive 2, Maddie, technically it's not wrong. It's just in what we're going to do later, you'd want to go ahead and FOIL it, but you understood the concept. Did you have this answer or the x plus 3, x plus 2 for the answer? All right, which did you have?
The x plus 3.
All right, GC, just FOIL it together and that'll help you out a little bit. All right, looking at the next one, we get a 9y over x squared negative 9. And we want to get an x plus 3, x negative 3, x negative 4. Now, on the surface, it looks like there's nothing that matches. If I were to ask a 4th grader, 5th grader, 6th grader, even a 7th grader or an 8th grader, is there anything similar between these? They'd say no. But you're smarter than an 8th grader. And smarter than a 5th grader. It's the TV show, right? This looks like x squared negative 9 to the untrained eye. But Noah, you know really this is what?
X plus 3, x negative 3.
This is x plus 3, x minus 3. So really, Noah, to your trained mathematical eye, the only difference is all of a sudden, poof, there's an x negative 4. And if it shows up in the bottom, gotta show up in the top. So 9y x negative 4, which I'm sure is what you wrote for your answers, right? But I want the distributed look. So
9xy negative 32. No, 36. Y.
There we go. And so this numerator with that denominator. Does that make sense? All right, but again, we understood the concept of what changed and putting it in the numerator, which is still good because foiling, it's easy to just tell you, okay, next time FOIL. Looking at the next thing, we had an x squared positive 2x negative 6 over an x squared positive x all equal to, what is it, negative, squared negative x, all times x squared x negative 1. This one's legitimately a little bit harder because they start us off like we did here without a factored form. Maddie, what is this in factored form? All right, so if you would factor, you would see here I have x negative 1, and over here I have x squared, x negative 1. Now this is something an 8th grader could answer correctly. Maddie, what changed from there to there? The x. So if I have an extra x here, I also need to put an extra x here. Maddie, what should be my numerator? There we go. Did you all figure that out? Or because you would have had to factor this one, we didn't figure it out? Did not. All right. You did have that. You had the x squared plus 2x plus minus 6. Okay, but you still figured out it was an x that changed. No, you didn't figure out the x changed. All right. Just like you did here, you had to, now we didn't write out x plus 3, x minus 3, but we certainly could have, right? And if we'd written it out, even a 4th grader could have told us that's what changed, right? And Chloe might have been able to tell us that's what changed. So if you need to factor to see it, like we did here, then do so, right? So the factoring helps you to see what changed. Looking at number 15 then, Noah. Well, actually, this one you might not have even needed to factor. We have a 3 plus y over a y squared plus 2y negative 3. And we're going to change it into a 5y squared plus 10y negative 15. I think we've got some 8th graders who could figure out what changed just by looking at it. And I think Noah can figure it out as well. Noah, from here to here, what changed?
5.
Right, you can clearly see a 5 has been distributed all the way through. And if that's been distributed through the bottom, so we get a numerator of
15 plus 5.
And there's our answer, the 15 plus 5y over the 5y squared plus 10y minus 15. Questions on that? All right, do you feel like you understand maybe a little bit better now, having tried it, even if we didn't succeed in every case, having tried it and now seen it, do we feel like we understand how to make equivalent fractions? Let me give you just a few more practice there at your seats, and then we'll apply this, though I think you probably kind of already know where this is going, but show you where we're going with this. All right, so 3 more problems for you. first thing we need to do was factor this up. Maddie, how does it factor? Good, either x plus y quantity squared or x plus y, x plus y. Either way, Maddie, what changed from here to there? An additional x plus y. So we have to do what? To get? Is that what you had? Ooh. Question?
No, I just put 7x times x plus y squared. Because I saw the x plus y twice.
Ah, you saw x plus y quantity squared here. Well, again, it didn't change. What changed is not that there's two more of them. There was already one of them here, right? We only needed one extra one. Does that make sense? All right. Noah, take the next one. We need to start by looking at this polynomial, factoring it up.
A plus b times a negative b.
There we go. Now, what changed from there to there? There's an a negative b that wasn't there before. The a plus b is not a change. That was already there. The a minus b is what's different. So,
8a negative 8b.
There we go. Multiply an a negative b times the top as well to get the right numerator. Is this what you had for that one, Maddie? All right. Taking the last one. Maddie, we need to look at this. Now, again, if this could factor, we should factor it also, right? In each case, these didn't really factor. We're looking at the denominators, factoring them up. So as we factor this, Maddie. I'm sorry? Okay. I noticed what you did there. All right. Right, two things changed here, a 2 and an x plus 4. So we have to multiply this by a 2, and then by an x plus 4. Let's start by multiplying it by 2, Maddie. And then multiply that by the x plus 4. And that should have been our numerator. Did either of you get that for the last one? You did not. What did you have, Maddie?
6x plus 4. I pulled out the 2 and then I don't know what I did, to be honest.
Okay, does it make sense now what you should have done? All right, and we're going to practice a little bit more with this as we go on to our next section. So we're not going to abandon this concept. We're actually going to build and continue it in a little bit more depth. Next section, your notes, finding the least common denominator of fractions. Finding the LCD, the least common denominator of fractions. You know where this is headed. You can't add fractions unless, class, you have a common denominator. And you know as well as I do, there will be times when you don't have a common denominator. You can't add it that way. You're going to have to change it, right? Well, we're not actually going to work on the addition process just yet, though we have already kind of looked at it. We're just going to look at what is the common denominator and what would these fractions be with a common denominator. Well, let's think back to our elementary days. Your teacher would have told you to find a common multiple. You would have listed out your multiples of 9. Say them with me. 9, 18, 27, 36, 45, and so forth, right? And then your multiples of 6. Say them with me. 6, 12, 18, 24, 30, and so forth, right? Well, a couple of those numbers happen to coincide. Which is the lowest common multiple, class?
18.
The 18, right? They both can turn into, if multiplied, into an 18. And so you would have said, well, let's multiply the top and bottom here by what to get the 18, class? 2. And so if you had to multiply the 9 by 2, you multiply the 2 by 2, class, to get 4. And here we said, well, let's multiply the top and bottom here by 3 to get 15, 18. So voila, they have a common denominator, right? But then you got to junior high. And the teacher said, there's another way. that always works, because some students don't know their multiplication tables that well. Some students can't think of multiples that quickly. But there's a method that always works, and it's called prime factoring. Oh yeah, that's what we've been doing all along, right? Is factoring. Well, you did it with numbers, though. You said 9 factors into 3 times 3, and you said that 6 factors into 3 times 2, and this is the way the teacher taught you to do it. For a least common multiple, or for a least common denominator, pick the winners. Which of these denominators has the most 2's? Well, class, obviously it's the second one, right? Because it's the only one that has any 2's. It wins by, now what's it called? Forfeit, right? It's a forfeit. It showed up and nobody else did. Which one has the most 3's? Well, the first one. The second one is a loser. We don't keep losers. We only keep winners. All right, go Crusaders. So, if we keep all the winners, that's a 3 times a 3 times a 2, class gives us 18. And now you don't have to think through multiples. You just pick all the winners when you factor the numbers. Now you do have to say, well, what did I multiply the 3 times 3 by? Oh, the 2 over here, right? So multiply by 2 to get the 4. What did I multiply the 3 times 2 by? Well, I already had 1 3, and I already had the 2. I was missing the extra 3. And that would give you a 15. And that's how you would have done it in junior high. Now, if we had this, maybe a 1/4 and a 5/8. Let's do it the old-fashioned way because it's easy. What's the smallest number that both 4 and 8 can turn into? 8 can turn into a 2?
No.
8 can turn into a 4? That is smushy. 8.
16.
They can both turn into 8.
Oh.
Let's do the prime factoring method. How can I factor a 4, class? 2 times 2. How do I factor an 8? 2 times 2 times 2. Prime factor. Prime factor. Who wins? He has more 2's. Loser, winner, right? So therefore, the winner of the 2's, the 2 times 2 times 2, or the 8, is my common denominator, right? And so here I'd say, well, that's not an 8. So I need to multiply it by a 2, and therefore the top by 2 to get 2 8's. That's already an 8. Did anything change? No. Then don't change anything in the top. If the bottom don't change the top, right? And that's how we would leave our fractions with a common denominator. How about this one? 1/15 and 1/6. Again, let's prime factor here. 3 times 5. How about the 6? 2 times 3. Now, as we come to collect our winners, the winner of the 2's is, of course, by default, this one. But which one is the winner of the 3's? It looks like a tie. Kind of like in basketball sometimes. When the guy is driving down toward the basket and you get into position right as the athlete gets there. It's a tie. What are they going to do? The ref doesn't even know. He just does the first thing that comes to mind. If the first thing comes to mind is this one, then you fall on the ground and you get up happy. And if he does this thing, you get up mad at the ref. He doesn't even know. He just picks one because he has to. Because when people crash to the floor, he's got to put his hand in the air and indicate there's a foul. And he doesn't even know who did the foul. So he's just going to call whatever he thinks it is. So don't get mad at the ref because he's just guessing and you know it. All right? And I know it. It's a tie. Just pick one. No, the first or the second one? All right, it's a block. All right, we're picking the first one. Loser. Okay, it's just whatever you want to pick in case of a tie. Now, there's a clear winner of the 5's. Again, it's a forfeit. But there's our 3 times 5 times 2 class 30. That's our common denominator. Now, this had the 3 and the 5. To turn the 15 into 30, I would just need to multiply by the 2 to get 2. And here I have a 2 and a 3, or a 6 in other words. So to get the 30, I need to multiply by a 5. So my numerator is a 5. And that's how we'll get the common denominator. That's how we did it in pre-algebra. We'll do the exact same thing with letters. Write this down. If you had a fraction n over 3ab, and you had a fraction of m over 2bc, when it's time to come up with our common denominator, all the winners need to be represented. We start with the numbers. I have a 3, I have a 2. They're both winners. by forfeit. What is 3 and 2? 6. Do this with me. I alphabetically will look at my letters. The A is the winner by forfeit. Write it down. There's a tie for the B's. Maddie, what do I do? Just pick one. B. You don't represent them both. They can't both be winners. Only one. It's not like, block and charge. Both teams get to shoot free throws. Everybody's ejected from the game. Okay, that's not how it works, okay? No, just one of them gets to be the winner, but it doesn't matter which one because it's just going to be a B anyway, right? We see a C. Anyway, and that's a winner by forfeit. And you realize all the winners are now represented. And that's what you're going to put in your denominator, is a representation of every single winner that's there. Now, Noah, here to here, what changed?
2. And then C.
2C. And if that changes in the bottom class, changes in the top. So my numerator, Noah,
2C.
Maddie, what changed? 3A. And if it changes in the bottom class, changes in the top. Maddie, what's my numerator? I better not be awake then. All right, and there's our fractions with equivalent denominators. Make sense? Representing winners. So, write this down in your notes. For finding the LCD of fractions, number 1, factor the denominators. Factor the denominators. Number 2, pick all the winners. Pick all the winners. The product is the LCD. The product is the LCD. And then, of course, change the denominators, or change the numerators accordingly. Change the numerators accordingly. Change the numerators accordingly. All right, let's take a look at another one. Well, 2 letters, right? Who's the winner of the M's, class? The second one, which is M cubed. What's the winner of the N's? Which is, so that's your least common denominator. Easy enough? At your seats, change the numerators. What changed? Then multiply it by the top. And Maddie, what is your first numerator?
5m squared.
I'm sorry?
5m squared.
Did the n change? Nope, don't mess with just 5m squared. Noah, what's the second numerator?
4m.
4mn? Did the m change?
Wait, no.
Nope, just the n changed, right? And only one more n, so yeah, just multiply it by an additional n, and so you get 4n. Here, the m changed by 2 m's, so put 2 of them up there, 5m squared. Does that make sense now that we've seen it? Let's take a look at another one. M over 3mn and 5 over 4n squared. Now, a couple things we're going to do here just a little bit differently because I'm lazy and I want to go as fast as I can and do as little work as I can. Sometimes you can make your life easier by reducing a fraction first. Do you notice the m's could cancel? Now, right now, do you see this m is a winner? Because it's the only one. So if I leave it in that denominator, I have to represent it because it's a winner. But if I cancel it away, I don't even have to worry about it. It doesn't exist anymore. Make sense? That's one strategy that'll save us a little time. So by reducing, an example of this with numbers would be something like if you were reducing, if you were trying to find a common denominator between 10/12 and 2/3. Well, right now it looks like the common denominator would be a 12, right? But you could reduce 10/12 to 5/6. Well, now all of a sudden the common denominator looks like a 6. So it just makes it a little bit easier. Does that make sense? Sometimes you can do this. So write that down in your notes if you would. Sometimes you can reduce fractions before getting a common denominator. Sometimes it helps, sometimes it doesn't. In this case, it looks like it's going to help because it knocks out something. It makes one fewer thing, one fewer letter that has to be represented, one fewer winner to have to worry about. Right? It's like at academic fair time. We've got these projects on display, and normally we give a first place, second place, third place, and I'm looking at the score sheets, and there's 2 projects that did really well, and like the other 4 or 5 all stunk. I'm like, I'm not even going to give a third place. Saves me time filling out a ribbon and writing up a little thing about them, right? Because I'm lazy. Why should I represent the M if I don't have to, right? I'm lazy. That's less work for me. Not even have to worry about the M, okay? So anyway, that's one shortcut. Another shortcut is this. I think that in 9th grade, we don't really have to prime factor the numbers. I think we can look at 3 and 4 and be like, yeah, what one number has 3 and 4 in it? 12. And if you put a 12, you are representing all the numeric winners. So for numeric winners, I usually cheat and take a shortcut. Now, if I can't figure it out, then I'll do the prime factor thing. But, like for instance, if I had, 2/9 and 7 over 15x squared and, an 8r cubed over 21z. Well, what number has 9, 15, and 21 in it? I have no idea. I don't know. Okay, well, this is where I'm like, okay, let's see. This is 3 times 3. This is 3 times 5. This is 3 times 7. All right, loser, loser. Winner, winner, winner. All right, 3 times 3 is 9. Times 5 is 45. Times 7 is, oh, help me, 315. That's my number. Okay, if I can't figure, there's no way I would figure out 315 without doing that. All right, so if there's crazy numbers, okay, fine. Factor them up, figure out your number. But 3 and 4? Do I really need to say 2 times 2? Hey, there's the winner of the 2s. I think I got 12, right? So sometimes you can save yourself work with the numbers. All right, now then, the only thing left, because we canceled away the m's, the only letter left is the n's. The winner is obviously, class, n squared. Now, from 3n to 12n squared, what changed?
4.
So multiply that by the 1 that's up here to get 4n. From here to here, Maddie, what changed? The 3. No n's changed, just the 3. So multiply by 3 to get 15. You're starting to catch on to how to come up with a common denominator. Do we see how reducing can save us work? Do we see how with easy numbers, just figuring out the number on our own can help us a lot? All right, let's take a look at another one here. Let's go with some polynomials now. 4 over x squared negative 2x and x over x squared negative 4. With polynomials, it is imperative that you factor or group them. Factor or group. So here, what would I need to do, Maddie? And then here, Noah.
Forgot what it's called.
Difference of squares?
Yes, that.
Right there.
To some difference of x and x. Negative, positive, 2 and 2.
Now here, just like I looked at m's and n's and a's and b's and things like that, I'm looking at x's. X negative 2's. This is all one thing together. x positive 2's, things like that. All right, so let's figure out our common denominator. Start with monomials first. Start with the easy things. So I always start with numbers, then I go with monomials, then I would go with binomials, then if there were any trinomials and so forth. So starting with the monomials, who's the winner of the x's? X. All right, put that down. He's a winner, right? He's a winner by forfeit maybe, but he's still a winner, all right? Who's the winner of the x negative 2's? It's a tie, so just pick one. Just put down x negative 2. They aren't both winners, okay? And it's not everybody gets a trophy. All right, a little participation trophy generation. Anyway, it's not two of them, just one of them, because neither one has more. Okay, and then who's the winner of the x positive 2's? Obviously, he is by forfeit, so he gets represented. All the winners get to keep going on in the next round. Okay, so do we see how to come up with polynomial common denominators? Now, what changed from here to here, class? X plus 2. So put it in the top to get
4 times x plus 2.
Or better yet,
4x plus 8.
4x plus 8. What changed from here to here?
To x.
Just the x. So,
X squared.
are you starting to get a feel for this? It's kind of like what we did yesterday, except you're coming up with your common denominator. And then what changed? But again, the common denominator is simply all your winners. Write this one down now. M over y squared negative 1, n over y squared negative 3y positive 2. Obviously, because there are polynomial denominators, class, you're going to have to factor them. Monomials, the factors are right in front of you. Polynomials, you got to turn them into the factors. All right, what's the common denominator? Maddie? Good. The y plus 1's a winner. It doesn't matter which y minus 1 you pick. Y minus 2 is a winner. So both fractions get a denominator that's the same, a common denominator of y plus 1, y minus 1, y minus 2. Noah, did you get this as well? What changed, Noah, from here to here? So I put it up here to get a new numerator of, well, 2m, but yes. All right, Maddie, is this what you had for your numerator? What did you get for this numerator? Good. And there we go. Do you feel like you understand what we're going to do just a couple of tonight? In your homework tonight, first of all, you're going to complete a homework handout to give you some practice on word problems. This is the main part of the homework, is this handout. Now, Brecken and Gavin, you'll find this handout in the description. There's a link to the PDF in the description of the video. So find that in the description, print it out, work out those word problems. You can write directly on this handout. That is fine. In addition, you're going to try just 2 problems like this. you're going to do page 428, numbers 23 and 31. Page 428, numbers 23 and 31. So you're just going to try a couple of these. And then like I told you, I'm going to have you practice more adding fractions where there's already a common denominator. On page 424, do numbers 4, 8, 12, 16, 18, 20. So every other even. No, that's not entirely true because 18 is not a multiple 4. So 4, 8, 12, 16, 18, 20. Giving you practice with those. Those should not take you real long as you draw the long line, put the denominator under it, figure out your numerator, right? So it should not take too long. Don't forget to try to reduce at the end though. You may be able to sometimes. All right, you are dismissed. Have a wonderful rest of your day. And Brecken and Gavin, looking forward to seeing you back on Monday.